This is part 2 of the normal distribution, right? So now we're going to look at how to use that 68, 95, 99.7 rule actually in situations. All right, how we use it by using our normal model. If you look at your graph and everything underneath, the area underneath the graph is a total of probability 1, all right? So we're 100% sure that something happens, that up until the mean would be 50%, right? And from the mean up to the end, something that's impossible, if you toss a coin 100 times, you'll never get 101 heads, would be 50 as well, right? So if you divide it in two pieces exactly with the mean as your cut point, you get 50-50 on each side, right? You have 50% chance of something getting smaller than 50 and a 50% chance of getting a value of higher than 50 heads in 100 tosses. All right. 68, 95, and 99.7 are still in here, and you see that I made lines that actually demonstrate those values. All right, let's go on. You see that, if we would do the same thing for the 68%, you see here in the middle, I've put it up, that from the center, from the mean, up to that 1 standard deviation below, it's 34%. Makes sense. Half of the 68. And on the outside, of course, the same thing. So between the mean and the mean plus the standard deviation, it is 34%. All right. If we do the same thing for the 95%, all right, on each side of the mean up to 2 standard deviations below and 2 standard deviations above, you'll have 47.5, right? 95 divided by 2. If you think about the 34, that was between the mean and 1 standard deviation. There's only 13.5% in between mean plus 1 standard deviation and mean plus 2 standard deviation. So in between those, it's 13.5. And you don't have to remember all these numbers. If you know 68, 95, 99.7, you can figure it out along the way. Same goes for 99.7. And we think about what's left there, you get a 2.35%, right? It might be good for you to calculate it again just to have an idea how you do it, but here are the actual values. Okay, and then the outside of that, because 99.7 is not 100% yet. So outside of that, so beyond 3 standard deviations below and 3 standard deviations above the mean, there still is a 0.3% chance on both sides. So 0.15 on each. Makes sense? But here you see it in wording. Okay. These are the values that we now got. Right, so 34, 13.5, 2.35, and 0.15. All right, so now what we're going to do is going to figure out what the probability is to get a value between the mean minus a standard deviation and the mean plus 2 standard deviations. All right, you might be able to see it, but I'm just going to walk you through it. All right, so this is the area that we're looking at. The area where you have 1 standard deviation below up until 2 standard deviations above the mean. All right, from the mean to 1 standard deviation below is 34. Mean to 2 standard deviations above is 47.5. If you don't know why, go back a little bit into the video. So we have a percentage of 81.5 if we add those two. But again, we're looking at probability, so we have to convert it back to probability, which makes it 0.815. Right? And a lot of times we just leave that 0 away. Okay, so we write this as a probability of x bar minus sigma smaller than or equal to x, and that smaller than or equal to x bar plus 2 sigma. Right, so it's exactly there in between, is equal to 0.815. And again, you can leave the 0.8 and the 0 off, the 0.815. All right, another one. And now in that exact notation, all right, P of x smaller than or equal to x bar minus sigma. All right, so think about what that means. It will say that we have a value. What's the probability of getting a value that's smaller than or equal to x bar minus sigma? All right, so if you look at the colors, this is what it means. All right. Well, again, if we just look at the percentages, we get a 16% chance. All right, means a probability of 0.16. So if you look at the top, that will be our answer. And this is how we use it. So remember the number 68, 95, and 99.7 to find out these values. And that's what it is. All right. Thank you very much for watching, and good luck.